Okay, so what we're looking at here is compound interest. And so we've talked about simple interest, and we know that basically the interest he earns only is only focused on that principal, at that initial amount that you've invested or you've got a loan on. That's that initial amount, and that's the only part that gets interest against it, used on it. Okay, but when we get to compound interest, it starts to differ a little bit, because what we're actually doing is we're actually doing what's got here called interest on interest. In a sense, so what's happening is, so we've got $1,000. Okay, so say we've got $1,000. Let's make it 100. Easy for my brain to work out numbers. Got $100. I do 10% of that. We've got interest of 10%. 10% interest. Okay. So after a year, I'm just going to do a year. I'm going to earn $10. Okay. Now, if it's simple interest, it would just be $10 each year. But with compound interest, that becomes $110. And then I do 10% interest on that. And so that's the idea between the different, that really sort of the basic difference between simple interest and compound is that simple is always going to be $10 each year. I'm only going to put $10 on. This one, I'm going to be 10% of this number. Then whatever number I get next, I'll do 10% of that. And that's what we're going to look at first. So I'm breaking this up into, this is going to be 3 separate videos. This theory is all in one spot, but I'm only going to go through the particular theory for what I'm going to go through today's compound interest tables, which is sort of what I was alluding to in my little bit of writing just before. And the following weeks will the following videos will be on other parts of compound interest. So let's look at this first example. So we've got $1,000 invested in for 4 years at an interest rate of 12%. So we know this is our, as it says, our VN. Okay. At an interest rate of 12% per annum. Okay. So remember, that's essentially out. We're not using these terms, but I'm just putting these out there for the moment. And compounded annually. So when it says compounded annually, it means it's the compounding part is done once a year. So that part there is once a year. That's important because sometimes what happens is you do compounding quarterly. Compounding quarterly means 4 times a year. Okay. So let's look at this, what we've got. So in our first time period, so our basically our V, what would be our VN, our previous term, is 1,000. Then I get my interest of that is 12% of 1,000. That equals 120. So my next term, my VN plus 1, is 1,000 plus 120 equals 1120. Okay. Now, what's the key part here is that what I get for essentially V1, which is 1120, as an answer, I now use as my previous term for V2, because it's effectively V1. So what you've really got here is this is V1, V2, V3, V4. Now, we'll be doing that a bit more later on, but I just want to give you the really clear part here. And that's like our V0, V1, V2, V3, V4. Okay? So what you actually see as you do, now I get 1120, that's my new amount. Then I do 12% of that, that's $134.40. So I add that to 1120, and guess what I get? 1254.40. And guess where I use that? I use that here. Then I do 12% of that, and guess what I get? 150.53, and that gives me a total. I don't know why I highlighted that part. But what I get is when I add this number and this number, I get 1404.93. And guess what I use here? That same number. Then when I get 12%, so you can see I'm doing 12% of that VN number, and that VN number is always changing. And so I get 1573.52, and I use that again here, and I add it, and I get a final answer here. Well, because that's what I'm only looking at for the first 5 time periods. Okay, and it's important to take note of that. I think, I know, because that's how the recurrence part. This is the recurrence stuff that you have to be really careful and really conscious of. And you'll see in stuff I've done previously in other videos where I've shown how you can calculate this on your calculator reasonably easily once you've got it set up. And in subsequent videos, I'll show you an example for compound interest, because the previous one I used was for simple interest, but it's the same process either way. Okay. But what's important from this point now is to recognize that we can actually change this 12% part. Okay, not change it, but we can express it slightly differently. Because the 12% part means is that the principal, so in this case, at the first off, that 1,000 part, is increasing by 12% each year. And then that total amount that I've earned, I've got another 12% of that. So I'm basically doing 112% of the previous balance. Okay, or we can define that as 1.12. And how do I get 1.12? Well, it's from this. Remember, 112 divided by 100 gives you 1.12, or whatever your percentage is. Okay, so the real key point with that is it's about how we express the numbers here. Because what this is what we call, and we'll see a different, not different, but a another symbol we use, a letter we use for it, but it's basically a compounding factor. Okay, all right. So it's basically a compounding factor, and what's happening is that's your interest, and this is the way we start to write it. So we're going to say 1,000 times 1.12, because remember that 1.12 is effectively 1, as in sort of the 100%, plus 12 over 100. Okay, and then we do it next time. So we've gone 1,000 times 1.12. So when we do, this example here, we go 1120 times 1.12. It's effectively doing that twice, so I can square it. Then I cube it, and then I can't remember what, to the power of 4. You're doing that 4 times. So I've got 4 here. And so basically what you're writing it as, you're writing it in this form here. This is the form you want to write it at the end. Because remember, this looks like, remember when we did recurrence relationships, and I went through the recurrence relationships? This looks like the common ratio type of recurrence relationship, which is effectively a geometric relationship. And we'll see that in subsequent videos that has a big impact on how quickly you're earning interest and what you're earning interest on. Okay, so this is what we've sort of done traditionally, and this is how we want to express it sort of when it comes to the exam time. Express it in this format here, and especially express it such that, I'm just going to write that again, I'm going to go 1,000, then 1.12 n, because n can be whatever. So if I've asked you for the 6 time period, I can put 6. If I ask for 3, I put 3, and that'll give me the time, the value for that particular time period, or that particular number of cycles that I've gone through. Okay, so that's a very important point to really take home and really use this format, and you can actually think of that, and we're going to see in subsequent videos. That's effectively 1,000. Remember, is our, in this example, 1,000 was basically our V0. So that's our V0. Then we've got our compounding factor, n. So this is our compounding factor. Okay. which is based on the 1 plus r over 100. But we actually give it a different name later on. So here's a worked example. So we've got here, Laura invested 2.5 grand. So that's basically our V0 for 5 years. That's our N. At an interest rate of 8% per annum. So every year that's per year, but with the interest compounded once a year. So that's once a year. Okay. So basically what you want to find out what does A equal, B equal, C equal, D, E, and F. So A, does percentage interest per annum earned on interest? Well, that's pretty easy. Okay. A is equal to 8% because it's 8% here. I meant to actually put that there. 8%, easy. B, well, remember what happens here. The Vn plus 1 here now becomes the new Vn down here. So guess what it's going to be? 2,700. C, we've got 8% of 2,700. Because remember, it's doing a percentage of what you get here. So that is the same. So guess what C is going to be equal to? 2,700. D, so D, so basically I've gone 8% of C, so 8% of 2,700 is 216. So what the Vn plus 1 here is, so D equals 2,700, because that's what was for Vn, plus 216. Okay, so yeah, and that is 2,916. All right, E is, so we've worked out what this Vn plus 1 is, and that's the same as that. And then I've gone 8% of that value gives me 251.94. So I'm going to add, so E is equal to 3149.28 plus 251.94, and that will equal 3401.22. And again, similar to what we did before, E here is the same as, sorry, I should say F is the same as E. Okay, because now that is going to equal to 3401.22. Keep in mind, just to sort of, so you can think about it, think like that's V0, V1. So this is your previous term, this is your next term. That becomes V2, that's V1. And that's effectively V1 as an answer. Shouldn't put it there. We'll go V3, that's your V2 answer. V4, V3, V5, V4. Okay, and that's the work example for this one. Thank you.